Well, hello there. I'm not sure how to start this video. Anyways, welcome to a new series. Hopefully something that goes uninterrupted. This series will be called RTP, which stands for Road to Physicist, where I document my journey to become a physicist, or somewhat of a physicist. As with every other series, I would start with an introduction. First of all, why do this? And my answer to that is so that I could make fun of engineers. In all seriousness, I'm studying physics because I want to, not because I want to make fun of engineers or anyone at all. I'd like to think that I have a decent plan in mind. Now, fortunate enough for me, I have a decent understanding of Calculus 1 through 3, but I think I need a review on Calculus 3, so I did just that on day 1. As you can see in the background clip, I had a 3D calculator open and LaTeX open. Of course, why not learn LaTeX while we're at it? So I started my review with Lagrange Multipliers and quickly got the hang of it with quotation marks. And I moved on to double integrals. That was pretty easy. Then I moved on to triple integral, and I finally got the hang of spherical coordinates. Unlike before, when I took my first Calc 3 course. I should also mention that I kind of made a boo-boo when I was typing on LaTeX. I just messed up Green's theorem, so don't flame me in the comment section. But for those who are unfamiliar, Green's theorem is basically a way to evaluate a closed line integral. Close meaning the beginning point of a line meets with the end point of the same line. A line integral, in its most basic interpretation, you could say it's the work. So Green's theorem states that the closed integral of the dot product between the vector field and those little chunks of the line, which is dr, is equal to the double integral over the region of the curve encapsulated by the closed integral of curl of f of the vector field times dA, which is small little chunks of area. Hopefully that wasn't confusing. Actually, it might not be confusing. It might just be straight up wrong. Of course, I mentioned Green's theorem's analog for work. There's also another analog for flux, which looks very similar, but instead of curl of f, it's divergence of f. And also the vector f is dotted with the normal vector, not the tangent vector. I of course reviewed surface integral next, divergence theorem, and Stokes theorem. Divergence theorem is pretty easy to grasp. It's the 3D analog for Green's theorem on flux. Stokes theorem is the 3D analog for the work/line integral. Man, this video is really short. So I'll try to explain Stokes theorem, divergence theorem, so the video lengthens. Divergence theorem states that the flux over a closed surface by a vector field f is equal to a triple integral of the divergence of that vector field. Stokes theorem, on the other hand, states that the closed line integral of vector field f dot dr is equal to the surface integral of the curl of vector field f dot n unit vector normal unit vector and ds are those little chunks of small surface areas. Hopefully that was understandable. Now, differential equations. Now I think I started with first order linear equations. I also got comfortable with integrating factors and converting Bernoulli equation which is a nonlinear equation, to a linear equation. First order linear equation. Although I'm not done with differential equations at the time of this recording, I should be done with it pretty soon. And after that, I'm going to start linear algebra, hopefully. Then I go to physics. But this video is still short. Actually, that's a positive for me because it takes a while to export my videos. So yeah, bye bye.